Hello, everybody. Welcome to the third video on visualizations in Python. My name is hoss.belyadi, and we'll continue on from where we left off last time. If you recall, last time we talked about creating these heat maps with, Pearson, Spearman, and Kendall coefficients, and we also covered the KDE plots and also coloring it by different colors. So if you haven't watched the first couple of first few videos, I highly recommend you guys go back and watch those videos prior to continuing. So in this lecture, we'll cover the cube distribution plots, and also we're going to cover the pair grid plots. So let's get started. So to do the cube probability plots, so I'm going to call it cube probability plots. Let's say SNS dot ECD F plot, okay, and then we'll just pass in DF. Let's just pass in EUR per 1,000 feet. Okay, and then as far as color goes, we'll just say green for now. So here we go. So you can see here the cube distribution plot. And what I'm going to do, I'm going to say plt.figure and pass in a fixed size and pass in 10 by 8. And here we go. So you can see here we have a cube probability plots, and this plot basically shows you, you can look at the P10, P50, and P90, kind of look at the range of your data and where most of your data lies. So it's a pretty good visualization technique to use to evaluate what kind of data you have. So feel free to look at the cube probability plots for different parameters. For example, if you look at well spacing, let's look at well spacing real quick. Here we go. You can see the P10, P50, and then P90. So feel free to play around with this plot and kind of understand the data that you have within your data set. So now, before going and covering the grid plot or pair grid, I'd like to first drop some of the features. So let's start off by saying I'm going to drop df.drop, and I'm going to drop some of the features. Let's actually go ahead and just do df.columns here. Look at all the features that we have, and let's drop, for example, some of these geologic features that we don't need. So I'm going to start, for example, with dip thickness, and I'm going to drop all the way to, for example, actually, I'm going to keep proppant per foot. I'm going to drop to pressure gradient. Okay, let's do that. And then I'm also going to drop EUR itself, because we have EUR per 1,000 feet. So if you remember, I said last time, when you're trying to drop if you're trying to drop columns, you got to put access is equal to 1. If you're trying to drop rows, it's got to be access is equal to 0. You can hit Shift Tab, and it will show you, for example, what you're looking into. So, for example, you can have access is 0 is the default. If you don't put an access equal 1, it's going to drop your rows, which you don't want. So you can see here 0 or index, 1 or columns, and default is 0. So you can always do Shift Tab and kind of refresh your memory if you forget. You don't have to memorize all these codes. I highly recommend to memorize some of the basic ones, but then if you forget, you can always do a Shift Tab and remember. Now, we want this to be permanent. We're almost done with this, with evaluating this data set. So what I want to do is I want to say in place is equal to true. If I don't do in place is equal to true, if, for example, in place is equal to false, it's not going to make these changes permanent. But if I want to make these changes permanently, I'm going to say in place is equal to true, and then do Shift Enter, run it. If I look at my df.head now, look at the data set now. You can see here, it dropped all the features except with some of these features. Now, I'm interested in doing a pair grid, which plots some of these features against one another. So that's why I wanted to make it a little bit shorter, so you guys can see better some of the visualizations that we're gonna go over. So let's start off by saying, let's just give it a name, say shell properties is equal to, I'm gonna say SNS dot pair grid. You just remember the P is capital and G is capital, okay? And then let's just pass in our data frame, which is basically this guy here. It has these columns here. And then let's also color code it using hue, H-U-E, by category, which is this column right here, which if you recall had new design versus vintage. So I'm going to call it category. And then let's go down now and let's do shell properties, okay? If you just type in shell or just the few, like first few words and hit tab, it'll auto-complete it for you. And let's do a dot map and do, I want to show the histograms or distribution plots on the diagonal piece. So I'm going to say map underscore diagonal like this. And then I'm going to pass in plt dot hist like that. Okay. And also I want to show the upper portion right above the distribution plots. I want to show the scatter plot. So let's do shell properties. I'm going to do dot map. Then I'm going to do upper, and I'm going to do plt dot scatter like that. Plt dot scatter. And then I want to also, cover the lower portion, and I want the lower portion to be KDE plots. So I'm going to say shell properties again, dot map. Instead of upper, I'm going to say lower. So you can see here, the only thing that is changing is map underscore diagonal, map underscore upper, map underscore lower. And also I'm passing in the kind of plot that I'm interested in. So plt.hist, plt.hit scatter. And then I'm going to say here, I'm going to say SNS dot KDE plot like that. Okay. Also, you can actually have more than one on the lower side, for example. So you can have more than one. So I'm going to copy and paste this. And instead of SNS.KDE plot, I'm going to do SNS.scatterplot. So you can see the scatter plot of what's going on as well. So if I run this, now let's just run this. If I run this, it's going to take a few minutes, not a few minutes, a few seconds. So let's see here. So almost done because we minimized the data. You can see here. So I created these parameters that I had: stage spacing, water intensity, well spacing, prop and loading, and also EUR per 1,000 feet versus one another. You can see these parameters. One thing that you note, the diagonal is right here. These are distribution plots. And if you recall, we color coded it by category. You don't have to. You can just not color code it like at all. For example, you can remove these color coding, and then the lower plot, the upper plots, plt dot scatter is the upper plot. So you can see these are the scatter plots right above where the distribution plots are in this area, and then the lower portions have two plots. They have the KDE plot and the scatter plot. So if you look at the lower portion, right below where this diagonal is, you've got the KDE plots and you've got the scatter plots on top of one another. So you can, for example, if this is too confusing, you don't want to do it by category, you can just remove it, rerun this. Let's see how this looks now. It should look a little bit cleaner because here we go. So you can see here, you got the scatter, you got your distribution plot on this side, and you got your KDE and scatter plots on top of one another. And you can see, for example, here's your well spacing against EUR per 1,000 feet. Here's your water intensity against EUR per 1,000 feet. Here's your proppant intensity against your EUR per 1,000 feet. And you can, and these distribution plots is basically your proppant loading distribution plot is right here. Your well spacing distribution plot, well spacing is right here. And basically that's how you can do it. So what I'd like to do is go back and add the hue again. Just do one more thing before we end this video. Let's do category. Okay. And let's just also add the name of category. So what I want to do is I want to say shale properties, and I want to say dot add legend, and inside of legend I want to say frame on is equal to true. Now I'm going to run this. Let's see what this looks like. And this is just going to add a legend on the side that will show right here. You can see here category, new design, and vintage. So you can see it much better. So we created this plot called a pair grid. And basically we're defining what we want in the diagonal, which we define as a distribution plot. In the upper portion, which we define as scatter plot. You can define whatever you want, by the way, in the upper portion. You can play around with this. And then in the lower portion, I defined two things. I defined KDE and scatter plots. And before we plotted this, I dropped a lot of these columns just so we could see better. And then I added this add legend at the end with frame on is equal to true, so we can see this a nice little category box on the side, so you guys can see better. This is the end of this video. We're going to continue on with the next video soon. If you like this video, please feel free to like, share it, comment, and hope you guys enjoyed it. Thank you so much, and we'll see you guys in the next video.